clean data, prepare. Yesterday, we learned how to clean data, prepare it to these formats, and how to go by our analysis. So today, we are just starting with the analysis. When you have the data prepared in this format and in SPSS for your thesis, the first thing you have to do is to inspect the data. And then how do you inspect the data? Most people, when they get the data prepared this way, they start with analyzing the demographic information. We don't do it that way. We have to first of all inspect the data. And we inspect the data by checking the reliability and the validity of the data. When we say the data is reliable, that means it can achieve whatever we want to use it for. So the main difference between reliability and validity is that with the reliability, they have something in common. For example, let me show you this particular questionnaire. I sent it to you in the group. Now, when you look at this questionnaire, at the section B, we said to examine the current facility management practices in Ghana and their environmental impact. So the emphasis is management practices in Ghana. So management practices. And then we want to measure it by these particular items. We are using these 10 items to see. The university has formal facilities management in place. Please, can you see the screen? Can you see the screen I'm reading from?
We can't
Hello,
see the
can you
screen.
No,
We can
no,
see the
please. No.
Okay. Can you see it now?
Yes, please.
Okay.
Yes, we can see.
Okay. Thank you. So when we want to measure the reliability and the validity, we always use it for something called the Likert scale responses. We use it on the Likert scale responses. So now our objective 1 says examine the current facility management practices. So we come to the section B of the questionnaire, and then it says to examine the current facility management practices in Ghana. So the facility management practices here is what we are trying to use these 10 items to measure. So these items, before they can measure a particular thing, that means they should have something in common. So we call it internal consistency. So they should have something among themselves, a common thing among themselves. So when they have that thing among themselves, it means they are reliable. And then the validity is it actually measuring the facilities management practices? So get the difference here. The reliability means they have something in common, which is in relation to what they are, because you are using this to measure this, you are using this to measure this, you are using this to measure this. That means these particular things, they should have something in common. That is the concept of the reliability. So are they internally, do they have something in common? Because they are measuring a common thing. So before they can measure a common thing, they should have something in common among themselves. So that is what we call the reliability. And then the validity is it actually measuring what we claim it should measure? So when we have it, measuring facility management practices, it shouldn't be measuring something like effectiveness of practices. So it should actually point to the fact that we are measuring the facility management practices. Please, do you get the differences? The reliability is about having something in common among themselves. So that is first thing we have to consider. The validity is, are they actually measuring what we claim it should measure? So that is basically the difference between the reliability and the validity. So when we have the data set, so this data set is related to the questionnaire we are just working with. So we have to check whether this particular data sets, they have something in common. That is the reliability. And if they are actually measuring facility management, that is the validity. So let's go back to the data. I'm back to the data. Can you see the data?
Yes, please.
Good. So that particular section B, these 10 items are measuring the facility management practices. So we want to check if these 10 items have something in common. So that is the reliability. So if there is internal consistency among them. So in order to do it, we have to, for them to be reliable, we have something called Cronbach alpha. So that Cronbach alpha should be greater than or equal to 0.7. So if it is less than or equal to 0.7, that means the data set is not reliable. So the Cronbach alpha should be greater than or equal to 0.7. In other words, we say 0.7 and above. If we had the Cronbach alpha that way, that means the data is reliable. Otherwise, the data is not reliable. And if the data is not reliable, that means it cannot achieve the objective of the study. So they can actually reject the data in that case. So let's start with the reliability. How do we do the reliability? We go to analyze. First, we go to analyze. With a drop down menu, then we look for.
All is well. When you get to the palace, we are here to deliver the message. Oh, Jim, Papa, what have I done?
So we move to scale. Then you see reliability analysis. You select it. So the variables you want to measure their internal consistencies, you push them into the items. So, and that is one of the reasons I always put them in sections so that you can see. So now when I'm pushing these items, I know where I am picking them from. They are in section B. So facility management practices. So I just named the data FM practice 1, FM practice 2 instead of their names. Then you push them here. So when you push them here, make sure the model here is on alpha. By default, it will be on alpha, but in some cases, if it is not on alpha, just click here and check and use the alpha. And that is the only thing you need from there. You don't need anything from here. Then you just continue. And then you say, okay. Where's my outputs? So we have our outputs here. So now what you should be interested in is this particular one, reliability statistics. Then you check the Cronbach alpha, the one it relates to, the value under the Cronbach alpha. The number of items we measured were 10, and the Cronbach alpha is 0.953, which is greater than 0.7, which means the data is reliable. The internal consistency is very high. So that means this data can be relied on. So in other words, we say In other words, we say these particular variables, these 10 items are reliable to measure this particular thing, the facility management. But is it actually, so this time around, what we just did is just to confirm that, yes, they can work together to achieve this. So the validity is, are they actually working towards it? So that is what we are going to do now. So we go back to the data set. We have the data set here. So in order to check the validity too, when we run the analysis, we have something called KMO and Bartlett's test. So with the KMO, it should be greater than KMO. It should be greater than 0.6. So 0.6 and above. For it to be valid, it should be, the KMO should be 0.6 and above. Otherwise, it is not valid. In otherwise, it means it's not measuring what we claim it should measure. And how do we do it? Then we go to analyze. Then we go to dimension reduction. Analyze, then you select dimension reduction. And then you come to factor. So we push the items we want to measure. The same in section B. You just hold the control key and be selecting. Then you push them inside. After you finish selecting, just use this arrow to push them inside. If you want them to be back, you use the same arrow, but I want them to be here. So now we had the variables here. So that means these are the variables we are going to work with. We want to see whether they are actually measuring the facility management practices. Then you come here, the extraction. Then when you open the extraction, you don't need anything here. You leave it. You come to the descriptive. Then you make sure this particular one, the KMO, is checked. That is the only thing you check from here. Then you say continue. Then you enter OK. These particular results, we will need them, but not for now. So for now, this is what we are interested in. So when we had the results this way, the first thing we have to check is the KMO. The KMO is Kaiser-Meyer-Olkin. So that's the meaning of the KMO, measure of sampling adequacy. Is it adequate enough to achieve whatever we are trying to measure? Or is it actually measuring what we are trying to measure? And what are we trying to measure? Facility management practices. And we said the threshold.
The KMO result.
Sorry?
We didn't see the KMO results. We didn't see it. It didn't appear.
You can't see it.
Yeah, the
Okay.
KMO results. KMO.
Okay. Okay. Can you see it now?
Yeah, please, I can see now.
Okay. So now,
But why is the
when
KMO?
this is the KMO, where we have, then here it will write the full meaning. The KMO is Kaiser-Meyer-Olkin. So this one is just telling you what it is measuring, measure of sampling adequacy. So is the sampling adequate enough to achieve the objectives of the study? So, and what is the objective of the study? That is the facility management practices. So when we check here, we say the threshold is 0.6 and above. And this one is 0.941, which is far greater than 0.6. So that means it is adequate enough to measure facility management practices. And now to confirm it statistically, that means we have to compare this one. This is the Bartlett's test of sphericity. So we compare it to 0.05. If this particular value, you choose a significance here. If it is less than 0.05, that means it is statistically significant. And let me explain what we mean by statistically significance. Whenever we say something is statistically significant, it means that that particular thing did not happen just by chance. So, for example, maybe there is an exams. When we finish, of course, I'll give you an assignment so that you practice it within the week. So I've given you the assignment. This particular group, we have some people that are staying in China here. Others are staying in Ghana. And I want to check their performance. So I noticed that those staying in China, they perform better than those staying in Ghana. Maybe the performance is just happened by chance because those staying in China are with me here in China. Maybe they had some opportunity. But maybe in other case, even if I'm not here in China, they can still beat those that are in Ghana in all cases. So if it is in all cases, it can just happen that way, or it can still happen as it is happening. That means it is statistically significant. But oh, it happened by chance. That means it is not statistically significant. So this one, for instance, the adequacy is not just by chance. It means that in all cases, these particular measures can still measure the facility management practices. Please, do anyone having a question on this? So whenever you want to analyze the data, this is the first thing you have to check, whether the data is actually adequate, whether the data is reliable. And if the data is reliable, is it actually adequate to measure what you are claiming to measure? So that is what we call the KMO. We use the KMO, the validity test, by considering the KMO and then the Bartlett's test. And then this one, chi-square here, this one is when we calculate it manually. So this one, we did not calculate it manually. So we don't, when we are reporting, we don't usually consider, but if you want, you can consider it. So this one, when we calculate it manually, then we try to compare it to something in a table. And then we read, if the table value is greater than this one, then it means that it is statistically significant. So it works the same as this one. So this particular one, chi-square value here, and then the significance value here, they work in the same format. So usually, because this one has a standard value we compare it with, we always use this one to do our reporting. Otherwise, when you use this one, you have to go and get that statistical table and then compare the measure. So we don't usually have that table, but this one, you have to compare it with the 0.05. So if it is less than 0.05, it means it is statistically significant. So when we do it that way, then this is another measure in the data set. So you have to do for each and every one of them. This is another measure. This for the section B. And then we come to the section C. To assess the effectiveness of these practices in reducing carbon emission. So now our emphasis is the effectiveness. So how do we measure? Do we actually have this? And under the effectiveness, we also have 10 items trying to check the effectiveness of management practices. So we have to do the reliability and the validity. We go through the same process. So when I do that one, the third one will be an assignment for you. You already have it. Then you go and then try it. So we have our data set here. We move to our section C. So that means these 10 items are trying to check the effectiveness of the measures. So we check the reliability phase. We go to analyze, then we check scale, reliability. Already we have the management practices. We bring them back. Then we go to items under section C. Then you select those items. You hold the control button and then be selecting. So now the same format we follow. We have our alpha. We make sure the alpha is checked. Then we just run. Can you see the outputs? Or you can't see?
Not yet.
You can't see it. Okay, let me reshare it. Can you see the output now? So
Yes.
now when you run it, you come to the reliability statistics, and then this particular value, we compare it to the 0.07. So it should be 0.07 and above. And then, but we have it as 0.09, which means that we can also trust the next set of data, the next objective. This particular data set can actually achieve the objectives. And for that matter, we move on to do the validity for that same items. So let's go back to the data. Now we take analyze, dimension reduction, and then factor. This one is already for the management practices. So we take them out and then we check the effectiveness. So carbon effective 1, carbon effective 2. I just short the names. Up to effective 10. So we have them here. As usual, we have to check if our KMO is checked. Yes, it's checked. Then we continue. And then we say, okay. Now we have our output here. What I notice is that when I run the output, it's open in a different window unless I reshare it. So that is why when I run, you don't see the output. So you have a lot of things. These ones, we will reserve them for when we are treating the factor analysis. So we don't do anything for now. We are interested in the validity. So now you check the KMO, Kaiser-Meyer-Olkin measure of sampling adequacy. We realize that those items are enough or adequate enough to measure the effectiveness or effects of carbon on management practices. And this is being supported by the significance value, which means it is statistically significant because this particular value here is less than 0.05. So now, even though this is what you do first when you have the data as part of your analysis, but when you are analyzing or you are presenting it, you don't start with it. That is what you do to test the data, but you also present this one to your supervisor. But when you are presenting, you don't use it to start. You use the demographic information to start. So now I have done some output. I want to show you how I report it or how we are supposed to report it. But I cannot share these reports for you because it's someone's work. I just want to show you. So because of that too, I made some little changes to the data such that our results will not be the same as this particular one. Please, are we together? So now, when I will finish running the analysis, you put the facility management practices, the number of items, they are 10. So that is what we have here. Our Chrombatch alpha, and then our KMO, and then our significance. So these are the 3 items, and you do it for each and every one of the categories. So now let's see how we report the results. Please, can someone read the first paragraph for me? Any volunteer to read it?
Okay.
Okay. Please, can someone read it for me?
Okay, I'm reading. The results of the reliability and validity assessment carried out to evaluate the internal consistency and construct validity of data measurement scales employed in the study are shown in Table 5. Combat
Good.
alpha
Please hold on small. So in table 5, we are measuring the internal consistency. That means it is the reliability. So when we talk about the internal consistency, whether they have something in common, that is the reliability. And then construct validity of measurement. So whether they actually measure, so that means that is the validity of it. So as presented in table 5. So you have to make reference to the table you are presenting the work. So this is the table number. So when you are presenting it in thesis form, this is how it follows. So please, let's move on.
alpha coefficients were used to assess the construct reliability.
Good. So now and that is why we said Chrombatch alpha coefficient were used. So all these ones are Chrombatch alpha coefficients. So let's move on.
The findings showed that every construct had outstanding internal consistency,
So
with alpha values higher than the suggested cutoff point of
good.
0.70.
Very good. So instead of they putting it one after the other, they said each and every one have outstanding internal consistency with alpha value greater than what? 0.70. So now we are now going one after the other. So let's move on.
In particular, carbon emission reduction effectiveness had an alpha value of 0.928. Facilities management practices had an alpha of 0.912, and net zero opportunities had an alpha dependability coefficient of 0.934. The result
Good. So we just repeat. Let's move on.
This result verified that 8 constructs questionnaire items reliability measured the underlying concepts.
So that means we are confirming that that particular data is reliable to measure any underlying concepts. The concept of facility management practices, the concept of effectiveness, and the other one. So now let's move to the next part, the KZMAO, the KMO.
KMO measure of sample adequacy and particular test of sphericity were used to evaluate construct validity. The sample size was sufficient for factor analysis because the KMO values, which varied from 0.887 to 0.914, were all higher than the.
Good. Now let me show you. They just gave a range of these ones. So from 0.6 to 0.887 to 0.914. So now let's move on.
Were all
were
higher
higher than the threshold, that is 0.7 0.60. So that means they all pass the validity test. So move on. Please, can you move on?
Butler's test of sphericity was statistically significant for every construct. That is, P is 0.001, indicating that there were substantial correlation between the measurement items and that the correlation matrices were not identity matrices. Yeah. Overall, table 5 finding verify that the research tool demonstrated adequate validity and reliability, offering a solid basis for further descriptive and inferential statistical analysis.
So now you see here, we said for further descriptive and inferential analysis. That means this particular analysis we just did is just testing the validity and the reliability of the data. That is not the actual analysis. But we have to first of all know whether the analysis is valid and, the data is valid and reliable. So if it is valid and reliable, we can now have the chance to move further to do any descriptive or inferential analysis of interest. That is what it is trying to say. So now let's also come here. When you check in the table, you realize that the statistical significance values or the p-values, these ones are our p-values. So you realize they are 0.000 for all. But when we come here, we reported it as 0.001. The reason is that even though the software will give us, this one is just like the error we are likely to make. So the error we are likely to make. So that means the lesser the error, the valid your output. So if it is 0.000, that means we don't have any error, but it can also be possible. So at least we should have 0.01% error. So if it gives you this way, you should at least include some error. So that is what we have here as 0.001 instead of us repeating the 0.000. Because if it were to be 100%, this particular value should have been 1. But it is not 1. And then, or this one should have been 1. But it is not 1 because the output there cannot 100% achieve our results. So at least, since it is not 100%, that means there is some level of error. But we are saying that the error should not exceed 0.05. That means it shouldn't exceed 5%. And that is why we are comparing it with the 0.05. So the 0.05, that is the meaning of it. That means 5% error. So the error should be less than or equal to 5%. That one, your results is acceptable. So if it is 0.001, that means it is 0.1%. If it is 0.01, that means it is 1% error and it is acceptable. So that is basically what we do first. So first thing we have to do whenever we get the data, especially when we have it in Likert scale form, which is analyze the demographic information here. So we go back to our data. So now we are certified that these particular items are valid and reliable. Then we can start our main analysis. So when we start, we have to, these ones are just categorical. And once they are categorical, we have to report them in percentages and frequencies. So the first thing we have to do is we go to analyze. descriptive statistics, and then we use the frequencies. Then we push all the demographic information. When we say demographic information that says something about the respondents. So the respondents, their gender, this particular information is about them. Age, their age groups, the position, their experiences, everything here is about them. These ones are about actually the work, the practices they are doing, or what they are about. So anything that says something about the respondents is what we call the demographic information. So we put all the information here. So we have gender, age, position, and then experience. Then we push them here. So we make sure it displayed frequency tables. And then we can also leave it in APA style. Then we just run. So when we run, we have our outputs here. Let me share the outputs. So we have our gender. How many males? We have the number of males being 273, females being this particular number. And then we had some missing values. That's 3. I made a mistake in the data set, but just understand what we are doing. And then we have our age group, those that are less than 25 years. They are 224, and that constitute 58.2%. Those that are within the age group 25 to 34, they are 95 in number, and that constituted 24.7%. And then those that are within this age group. So when you finish, you have to put these 4 items in one demographic table when you are reporting. And now when you have the output this way, you have to make sure you get it into Word. You can't report it here. And how do you get it into Word? You have to import. Export it. And how do you do it? You go to File. And then you see Export. You select Export. Click on it. It will open this particular window. Can you see the window?
Yes.
Okay. Then you come to Browse. And then tell SPSS where you want the document to be. So by default, SPSS will direct you into documents. Maybe you want yours in desktop. Then you look for desktop here. And then you have it on desktop. And then you name it, give it the name you want. Maybe I want it to be GHG. Sorry, let me just make it GHAN. And then you save. Then you say, okay. Now, when you go to the desktop, you should be able to see this particular resource. So now let me see. Let's go to the desktop and then find it and look for it. Can you see my screen?
Yes.
Can you see I'm on the desktop? So we are looking for it from the desktop. Good. And here is it. Then when we open, SPSS will give us things that we need and things that we don't need. So yours is just to take the things you don't need out. Now it has added it to the reliability outputs. So we take everything here out. This reliability is one of our resources. or something that we needed. And then here, we don't need these ones.
Please, we can't see you.
You cannot, okay. Can you see? Can you see can you see it now? Good. So now it was like this. Let me undo it. When you open it, you will see some items that you do not need. Then you just come and then take them off, leaving only the items you will need. We don't need this one too. Then we take it out. This was one of the outputs we generated for the reliability. So we need it, so we leave it that way. And then we don't need this one. This one, we don't need it for now. It is very useful in our analysis, but we don't need it for now. And then total variance explain, we don't need it for now, but we need this one too. So we just take everything that we don't need. These are the other. So over here, you just have to take everything that you don't need, leaving only things that you are interested in. And because SPSS, when you analyze, it will just give you a lot of things. Usually when I analyze, I just copy from the output and go to Word and then paste. I just select only the things I needed and then go to Word and paste. So now you use this one to prepare the APA table as I did. So let me show you how I prepared it in the output, the one I did for the person. So this is the work. So now we have our demographic information here. And that one should be the first part, because when your supervisor check, he has to know the nature of the people who answer the questions. Are they grown up? Are they more than, like, are the males more? So when the person look into this particular data set, the person will realize that the males are dominating in the study, which constituted almost 70%. Sorry, almost 71%. And then the females are also more, but they are not much as compared to the males. So here you are just describing. So when we say descriptive statistics, we are saying that you are describing the important feature of the data, but you do not draw conclusion. What you are reporting is there are more males in the study as compared to the females, and then the majority of them are below 25 years, which means that most of them are younger. Like, there are young people in the study, more young people as compared to the grown ones. So you can check here. You realize that those around 55 years and above were only 6, and that is 1.6%. Then you just describe the middle age group. Then you come to this role too and then describe them. And that is how we report this one. So can someone read the demographic here? I want all of us to be engaged.
Okay,
That's
I'm
why I
ready.
want someone to do. Okay.
The demographic details of the study participants are shown in table 1.385, valid responses in all.
Sorry,
Examined. In all.
in table 1.
Oh, okay.
In table 1.
In table 1.
So
Oh, okay.
385 valid responses.
385 valid responses in all were examined.
Yeah.
In terms of gender distribution, 70.9% of respondents were men,
Good.
28.3% were women, and 0.8% identified as other.
Good. So those people
This
did not
indicates,
reveal their identity.
okay. This indicates a male-dominated workforce within facility management related roles in Ghana.
So
Higher,
this one, that means they are just describing what we have seen. So when you look at the
okay.
data, you realize that the males were dominating. So, but the person did not draw conclusion. He's just saying what he has seen, just describing. So let's move on.
In terms of age, most respondents were below 25 years. That is
Good,
58.2%, followed by those aged 25 to 34 years, which is 24.7%, and
good,
9.4% of respondents were between the ages of 35 and 44.
good,
6.2% were between the ages of 45 and 54, and only 1.6% were over the age of 55. This suggests that the facilities management workforce is relatively young, with strong representation from early career professionals.
good. So now when you look at this report, that means we are just describing what has happened here at the age group. So that's what I just spoke to you about. Let's move to the next one. In terms of role or position, can you move on?
Okay, in terms of role or position within the university, the facilities management team accounted for more than half of the responses. That is 53.5%. Academic
Good,
staff, 25.5%, and technical staff, 21.0%. Came next, suggesting that the study was successful in gathering opinions from academic and operational stakeholders engaged in sustainability and facility management. About half of the respondents had 1 to 3 years of job experience, making 49.6%, whilst 22.3% had less than a year.
good,
17.1% of respondents had 4 to 6 years of experience, whereas smaller percentage had 7 to 10 years, that is 6.5%, and more than 10 years, 4.4%. The fact that a sizable portion of the respondents are just starting their profession is further supported by this distribution.
good. So now this one, we just had the work and then we are just describing what is happening. So now when you are describing this one, you are just mentioning the range, those that are less, those that are more. And in some cases, some of the supervisors, whenever you are reporting this work, they don't want you to be repeating the figures, but other supervisors, they like it. So if I'm showing some analysis more of them were within the age group. Sorry, few of them were within the age group, 55 years and above. So it depends on the supervisor. Some of them, they will tell you that, do not repeat what is in the table again. So in otherwise, you are just narrating which one is more and which one is less. Please, are we together?
Yes, please.
So when we have it that way, now we understand the demographic. So the next thing is we can also analyze the descriptive by using graphs. So let's go back to the data set. Can you see the data set?
Yes, please.
So now, if you want to represent it by visualization, because most supervisors, they will also like to see the visual aspect of it. So we are going to use this same demographic information to do it. So the graphs we are going to consider, we'll consider the pie chart, bar chart, histogram, and then line graph. So I'm going to explain the 4 of them this evening. So now let's start with the bar chart. The bar chart and the pie chart, they all measure qualitative data. At the beginning, I explained to you that qualitative data is data which responses are not in the form of a number.
Hello, please.
Qualitative data refers to the data which responses are
Dr.
not in
Baz.
the form. Yes.
Hello. And
Hello,
please,
I can hear you.
it's 7:55, 11:55 in Ghana. Can we break for 5 minutes and then continue with the graph at 12?
Yeah.
That's 8.
When it is I want when it is 8 here, and then when it is 12 there, then we break for
Okay.
5 minutes.
Okay. All right. Thank you.
Yeah. So now our next thing to do is the graphical work. So we want to deal with 4 main graphs today. We have the bar chart, and then pie chart, histogram, and then line graph. So with the pie chart and the bar chart, they all measure qualitative data. And like I explained to you earlier, qualitative data are the non-numeric data, which means their responses are not in the form of a number. So for example, gender, male and female. And then mostly when we want to analyze this particular data set, the one with less categories, we use it for the pie chart. The one with more categories, we use it for bar charts. And then if we also want to measure the percentage or, pie chart, we use a circle. And then by dividing the circle into categories, so we say circumference or area of a circle. But in this one, we will use percentage. So that's what we always use in research. So now we will start with the the bar chart. Like I said, the bar chart, it takes more categories. When you use it for things with less categories, it's not attractive, even though it is not bad. So how do we do it? We use everything about the graphs, we use the graph menu. So you go to graph, and then you go to legacy. Then you see the drop-down menu. Then you choose the bar chart. Let's start with the bar chart. Then we select simple, and then we define. I'm showing you something here. When we go to the graph, legacy, bar charts, and then we select simple, make sure the first one, summarize for groups of cases. Make sure that one is checked before you define. So now, which particular variable? Now, when we want to represent bar chart, we can represent it by the number of cases. We can also represent it by percentage of cases. We can also represent it by cumulative number or cumulative percentage. So it depends on how you want to report it. So mostly I like reporting in percentages. So I have to select percentage of cases. And now you select whatever you want to do into the categories axis. So I want experience, then you put it here. And that is all you need to do. And then you say, okay. And here is our output. So please, can we take 5 minutes break and then come back and continue?
Oh, okay. All right.
So we'll be back in 8:05.
Okay, good.
Bar graph. Most people or most supervisors, they don't like it when you just run the graph and then you see something just percent. They don't like it that way. So for that matter, you have to make some editing to it. And how do we edit it? You can highlight the graph. When you click on it, you see this right arrow pointing to the graph. That means it's been highlighted. There are two ways. You can just, after it is highlighted, you can right click and then down there you see edits and then you choose it. It will open in a new window. Then now you can now make the changes. Please, can you see the new window? Because sometimes when I open a new window, you don't see. I want to be sure whether you can see my cursor moving. Please, can you see it?
Yes, please. Yes.
Okay. So now it will open in a new window this way. So what you have to do is, first, when it opens this way, that is when you can do the editing. Otherwise, where we had the output, you can't do editing. So click on the percentage first. When you click on it first, you will see it being highlighted by this ash rectangle. So click again. It will start blinking. It will give you a way to type whatever you want. So in our case, we can put percentage of respondent. So instead of just percent, so you write percentage of respondent and you put enter. So this particular area has been edited, and then you come and then we can see.
Please, I can't see you.
Okay, I'm coming. I'm resharing it. Can you see? Can you see it now?
Yeah, but where did you type for you to get the chain effect?
I'm coming to do it, but I just want to be sure that if you can see my cursor rolling on the graph. Can you see?
Okay,
Can you
No,
see
it's
it
not.
moving?
no.
You can see my mouse pointer.
No, we can't see.
Please, I think we can appreciate it better if you can go back again on how to make the changes or edit the graph,
I'm going
starting
to do
from
it.
where the arrows. All right.
Can you see my screen now?
It's now loading.
Can you see it now?
Yeah, we can see.
Okay. So now when you run, you get the output this way. Here is percent. And most supervisors, they don't like it that way. So unless you make some editing. And how do you make the editing? The percent here, you cannot change it here unless you open it in a different window. So we have two ways of doing it. First, you just click and then the graph will be highlighted. Then you right click on it. Under it, you see edits. So when you do the edit, it will open in a different window. Please, can you see the new one? Or you are still seeing the old one?
Yeah,
Where we
we are
have the
seeing,
percent.
we are seeing a new one.
You can see the percentage of respondents, right? Can you see it that way?
We can see the tab that came with chart size variables, only that.
No, can you see on the left side, percentage of respondents? The graph with that, the percentage of respondents, can you see that one?
Not really.
No, it's not showing.
Okay. I'm coming. Can you see it? Can you see it now?
Yes, we can see it now.
Okay.
Yes.
So when you do it that way, it will open in a new window this way. So you see the percentage here. So don't just do the percentage, click on it. When you click, it will highlight and then click again. Like when you click first, it will be highlighted by this ash rectangle. Click again, then it will start blinking. You can clean whatever you want and then write whatever you want. So I'm just deleting. It was percent this way. This initially how it was. Then I click on it and then click the second time. It's not double click, but click wait and then click again. Then you just make the changes. Percentage of respondents. And then you say enter. So that particular side will change. And then here, you don't just have to leave it experience, years of experience. So that is what the person is actually measuring, just that we entered it experience. So make it very clear. So years or year of experience, years of experience in a way that the person who, the supervisor by seeing it will understand. So now we have just, our first editing to the graph is just by changing the labels, how we label the x-axis and the y-axis. The next thing you have to do is sometimes they don't like it when it is in. You click on the bar you want to change the color. For example, as I click on this one, you realize that the other bars were not highlighted again, except this one. Then you come here and select the color you want for it. And then you say apply. Yes, then you say okay. You realize that one will change. Sorry, I think. So I just apply. And what could be wrong? Let me take it again. Let me click elsewhere. So okay. So now we have our graphs here. So sometimes you just want, you don't want to, we could see that, please, can you see the graph first? Can you see the graph?
Yes, we can see it.
Okay. So we could realize that those within those with 1 year less experience or less than 1 year experience, you see the one with the 1 to 3 years experience that has the longest bar, followed by the one with less than 1 year experience, and then we have 4 to 6 years experience, and then to 7 to 10 years experience. So, but no one can actually see what is happening. So what you have to do is, this one is by what percentage, this one is by what percentage. So what you have to do is to show the percentage values. So most supervisors, they prefer that. So what you do is you just click on one of the bars and all the bars will be highlighted. Then you right click, just put the cursor on one of them and right click. At the down, you see show data labels. Then you click the show data labels. I think something is not right here. Let me reset it. I think. Please hold on a minute. I'm canceling my output. I'm taking it again. So I have my graph. I go to the legacy. I'm just repeating the same process. So we have it this way, and then we have to do the editing. Can you see the editing window? So now, the first thing we have to do is to change the percentage. Percentage of respondents. And then here we make it year of experience. Year of experience. So what you have to do is, maybe you have to get some information like the data set or the values in which each and every one of these categories represents. So you have to right click. Under it, you see show data labels. Then when you enter the show data labels, the actual values should replace it. So now the 1 to 3 years experience, they are 49.6%. Those within experience in less than 1 year, they have their experience for 0 up to 1 year or less than 1 year is 23%. And then followed by this particular group, which is 17.1%, in that order. And then sometimes maybe you don't want them to be of this same color. Maybe you want to change the color of some of the graphs. Then you click on, when you click first, you realize that the whole of the bars will be highlighted. You can see the ash rectangle highlighting all the bars. So right-click the bar you are interested in. So I click on the first bar here, and then you can fill and border, and then select a color. Maybe I want this color for the first bar. Then you apply. When it says okay, and then the second bar, you click on it. When you click, this particular side will show the color of that bar. And then you select the particular color you are interested in. So maybe I am interested in the red color. and then you apply. Yes. Then you select another one in that order. So when you select this one, let me do that one, and that will be the last color will change. Yes. So after you finish with every editing or all the editing you are supposed to do, then you just click elsewhere.
Doug,
Yeah.
please, where did you get your properties?
Sorry?
Sorry. Where do you get the properties formatting toolbar?
You have to
Where you
double
selecting
click.
your colors?
You have to double click on it. It will come this way. Are you seeing my graph?
Yes.
You are seeing the new graph, the edited one.
Yes, please.
Okay, just click
Oh,
on
okay.
it.
Okay, I've seen it.
And
I've
then
seen it. Thank
you
you.
see,
Thank you.
okay,
Yeah.
fill and border. So when you click elsewhere, you realize that now that particular graph has been changed. Then you copy it to anywhere you want and then work on it. Now, our next thing to do is the pie chart. The pie chart is always good when you use it with items with small categories, maybe gender for male and female. They are not much. So let me go back to the data. So we have our graph. We are going to do pie chart for gender. So we go to legacy. And then you look through the chart. You can see pie chart. Leave it on the first one, summaries for groups of cases. Leave it on that one checked. And then you define. So when you define, you select the variable you are interested in and push it in the define slices by this particular site. So we are interested in gender. So we push gender in define slices by. And mostly it is good we use percentage of cases. It is more preferred by supervisors than the number of cases. So we use percentage of cases, and that's all that we need for here. And then we say, okay. So we have our output here. We have our output here. Please, can you see the outputs?
When did you come? Huh? When did you come? I come time ago. You were not available. I was inside.
Hello,
We can
please.
see.
Okay, now the pie chart here has been highlighted. So what can we do? We could realize that the males is represented by blue and the female is represented by this color. We could tell that the males are more than the females in the study. But how do we justify it? How do we see the values? So we have to go through what we did when we're dealing with the bar chart. So you can double click on it, or you just right click and choose edit. It will open in this window. So when it opens that way, maybe you want the values to be on it. So click on it once first, and then you see it being highlighted. You see some rectangles highlighted all. And then just right click on any part of it, and then you say show data labels. So you see the values now appearing. The 71% of the males, and then the 71.47% of the males, and 28.53% of the females. Maybe you are not interested in this color. You just go through what we did for the bar chart. Which side are you not interested in? When you click on it first, the whole of it will be highlighted. Click on where you want to change the color. Maybe I want the male side. Then you click again. you realize that this particular side alone is being highlighted. And then you go to the graph and then you say apply. Yes. So that particular color has been replaced. And sometimes, maybe if you want to make it style by separating the males and females, or maybe
Please, it hasn't changed. Mine is the same as the old one. I
your
don't know
own
if
did not change.
Yes, there's no change.
Yeah, it's actually the same.
Can you see it?
Oh, okay.
Yeah, yeah.
So what I did was, maybe I am not interested in this color. You click, when you click first, the whole of it will be highlighted. Click again, and then that particular color alone, you see in the preview, maybe that is not what you want. Then you come here and then select the color that you are interested in. Maybe I want this part light red, and then you say apply. It will say the border, it should be greater than 0. You say, okay, you should adjust it to 0. It's referring to this particular one, the weight. So you say, okay. So, okay, no, it should change. But I don't know why. Let me adjust it here. I think something is wrong. I have to redo it and then show you. So this is how we had it when we ran the analysis. So you double click, it will open this way. So the first is we have to make sure the values are on it. We right click, we just click on it for the whole of it to highlight. Then we right click, and then we show data labels. We select that one. You see the values now on the graph. Then the one you are interested in, maybe you are not interested in this color, then you click on it and then go back, click on the one you just want to change. Maybe I want to change the male's color. You click on it. You see it preview here. That means that particular side has been highlighted. And then you select the color you want to replace it with. And then you say apply. You say okay. So that particular side will be replaced. And maybe you just want to make a little style to the graph by separating the male side from the female side. That is exploding. So you can click here, just click elsewhere of the graph, and then click on it again. You realize that the preview is not showing. That means the whole of the graph is being highlighted. So place the cursor anywhere of the graph and then right click. Down there, you see explode slice, and then you select. You realize that
Still
the
the
graph.
same. I'm not
Sorry,
seeing
Doc,
any change.
we are not seeing anything. We are not seeing anything now.
Okay, I'm coming. Please, can you see it now?
Yes,
Can you
please.
see?
Yeah, we can see it now, but we don't know how you arrived at this
Yes.
place.
I'm coming.
Can you kindly go back and
I'll redo it again.
Okay.
So
okay,
now
thank you.
you can see that the whole of this one is being highlighted.
Mhm.
The male side is highlighted, the female side is highlighted. So I'm bringing it back. You can just right click anywhere of it, and then you say return slice, and then it will come back. But what I did was I have to right click anywhere of the graph, and then you go down, explode slice, explode slice. When you click, it has been exploded. It's been separated. A female part is being separated from the male part. And if you want it to come back together, you right click again, go to the down, and you say return slice, and it will come back. So if this particular way is okay to you, you just click elsewhere, and then the editing will take place. Please, can you see it now? The changes have
But
now.
when you click return slice, it hasn't returned.
No, I did not click for the second time.
Oh, okay.
I was just showing you. So when you have it this way, please, can you see the slice? I want to
Yes.
do it to return. So when you click on it, then the down, return slice, then it has come back. Can you see it coming back?
No.
No, I'm coming. So can you see the graph now? Can you see the
It's
graph
still
now?
separated.
It's still
Okay, yeah.
separated.
Now
You
it's
can
okay.
see. So what you do
Yeah, it
is
has returned back.
when you right click on it, down here, explode, and the graph will separate. And then you right click again if you want it to come back, and then you go down, return slice, it will come. Can you see that? Can you see it exploding and coming back?
Yes.
Okay. So
Yes,
basically,
yes.
that is how we also edit this particular one, the pie chart. So now our next thing to do is the histogram. Let's go to the histogram. And the histogram, it is used mostly, or it's used for qualitative data. The histogram is used for qualitative data, but this particular data we have here is used for quantitative data which responses are in the form of a number. So now let me first, please, can you see the data set? We are on the data set.
No, it's still the
No.
pie chart showing.
Okay. We are on the data set now.
Yeah,
Okay.
no, it's okay.
So I have to now make some transformation, like I explained to you earlier yesterday. Maybe I want to use histogram to represent the practices in facility management. So I have to transform it first, the data first, because we have one aspect of analysis is it summarizes the data. So we have to transform it by summarizing it into one variable. Instead of practice 1, practice 2, practice 3, up to practice 10, we just have to get practice for once. So we go to the transform, compute variable. So by default, it will be this way. And then you have to give it a name that you want. So we say practice. And then we come to this side, the all. Double click on it. You see other functions at the down. Look through it and then you select the mean. So double click on the mean. It will appear here. And then you put like we did yesterday. So practice 1. And then you move the cursor across the comma. Practice 2, you put comma yourself. Practice 3, comma. Practice 4, comma. Practice 5, in that order. When you finish the practices, then you delete the question mark.
Dog, I'm lost. So
Which side?
how did you come here?
How did I get here?
Yeah,
I'm taking it again. What you do is you go to transform.
transform. Okay.
Transform on the menu bar.
Yeah.
Can you see it?
Yes, please.
And then you select the compute variable. So when you select, it will open this way. Now what you do is you just have to get mean. Over here, you can't get mean among these particular ones. So you select all to show all functions. And the other functions that are not here will appear here. So you go through. And then here, you can see the mean. You can see mean here. Double click on it. It will appear here. So now it will be showing the question mark. So you select the first variable. Then use the cursor across the comma. It will say first variable, comma, and then use the cursor across. You put second variable. Then from after the first comma, the other commas, you have to be putting it yourself. And then the third one, put comma, fourth one, fifth one, in that order until you exhaust all the practices. So now we have exhausted all the practices. We have to delete the question mark. So when you delete it, now this one should highlight. Sorry, I have to give it a name, practice. So I have to give it one name, call it practices. Then you say, okay. So when you say, okay, now you go back to the data set. You realize that a variable called practices has been created. Please, have you seen that practice variable? Can you see that new variable, the practices?
Yes.
So we can use this one to draw a histogram. So how do we draw a histogram? You go to graphs, and then the same legacy dialogues. You see histogram at the bottom or at the down. So now over here, you have to select the variable that you are interested in. So by default, it will be this way. So you select the variable that you are interested in. We are interested in the practice. So you push it into the variable column. And then you check this one. I will explain that one to you later. Display normal curve. When we are doing normality check, normality of data, I will explain that one to you, but you have to have it. And then you say, okay. So you find your output this way. Please, can you see the outputs?
Yes.
Good. So now our mean practice is 3.20 with standard deviation of 0.917, and the sample size is this. So this is our histogram. So over here we can make the editing by changing, instead of frequency, we'll say we have to first of all make the editing. By editing it, we have to open it in a different window. So double click on it. It will open in an editing window. Please, can you see the editing window? Or you are still seeing the old one? Can you see my cursor moving?
We are still seeing the old one.
You are seeing a small chat box variable and the rest.
This
Okay,
one, can
it
you
has
see this one?
changed. Yes.
Can you see this one? And you can see this one too.
Hmm?
You can see this one too. Where the histogram. Okay. So now you place the cursor on this one. When you
It's
click
not
on
moving.
it, it's not moving.
Yeah.
Okay, I'm coming. Can you see it now?
Yes.
Okay. So it will be this way. So what you do is the frequency, you can present frequency to your supervisor. So it's when you are reporting it, this is every supervisor will know that this is you just bring the output straight. So you have to make some changes. So the frequency is just the number of people. So instead of the frequency, just come and then do the same editing we did in the bar chart. So number of participants or respondents. So we have, and then you also make some editing to this one. This is the variable name we have created, but over here we can just make it facility management practices. Then we leave it this way. If this editing is okay, then we can click elsewhere. Then the changes will reflect. And then we just take it this way and go and then paste it in our Word format and then report. So basically that is how we go by the histogram too. And the next one, this one I will explain it to you later in our normality test. Because if I start it now, it will confuse most of us. And then we have to just stick to what we are supposed to do for the day. I don't want to bring different things to confuse us. If I go into this one, I have to go into other things. So our next one to consider is the line graph. So let's go back to the data. And then with the line graph, it is also used for quantitative data, like the histogram. The histogram is used for quantitative data. It's not for qualitative. The line graph is also for quantitative data which responses are in the form of a number. That means this particular one is best for it. It's also good for line graph. But this one, for instance, it compares the values with some categorical variable. Usually we use it when we are dealing with time series data. So in respect to time, maybe 2000, 2025, 2026, 2027. But if we don't have the time data here, we can either create or we just leave it that way to compare. So let me just create some for the sake of our learning. Let me just create. So I just add another variable here, and then I call it year. So I come to the values here, and then I choose one for 2010, and then two for 2015, three for, sorry, three for 2020, and then four for 2025. Then, okay, I go to the data view, and then let me just enter it right now and we continue. So we have 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So let me just copy it and then just be pasting so that I can finish it fast. It has even exceeded. So let me just delete the other ones. I clear. So now we want to check if the perception here differ according to year group. So that is basically what the line graph is about. We want to check the perception based on year group. If the perception in this particular year is different from this particular year, let me make this one. If it is unknown, automatically it will choose scale. So what we will do is we go to graph and then legacy. Then you choose line. Then let's select the simple line. Make sure the first item, summaries of groups of cases, is checked. Then you define. So over here, the line graph you are dealing with, it is not categorical. So you can't use number of cases or this. You choose other statistic. And then you choose other statistic, example mean. And then you now select the variable of interest. You are interested in practices. Because you want to measure practices, you put it under the variable. And then example mean. So you go to statistics here, change statistics, go there and check whether it is actually on mean. You want to compare the practice mean values based on the years. So check if it is actually mean. So go there. If it is mean, just say, okay, continue. Otherwise, you can change it to any statistic that you want to use. If you also want to base it on median, you can choose median values, but we always prefer the mean values. And then you say, okay, then what are you measuring it on? You are measuring it on years. So you select the year and put that one into the category axis. So now you don't need anything here again. You say, okay. So we have our outputs. Let me show the outputs. Please, can you see the outputs? The graphs, the line graph. Can you see it?
Yes.
So 2010, 2015, 2020, and then 2025. So the perception as time increases, the perception also keeps increasing. So now the mean practices. So we can also do some editing on this. Maybe you want to see the values on this particular graph. In 2010, what was the mean perception? 2015, what was the mean perception? 2020, what was the mean perception? And then 2025, what was the mean perception? So you can do it as we did the other way. Double click on it. It will open in a separate window or a new window. So we have it this way. Can you see it in a new window? So now click on the black line, the line. And then when you click, you realize that it's been highlighted. Put the cursor on it and then right click again. Under it, you say show data labels.
It's not
And
moving.
it's not moving.
Yes.
I'm coming. Can you see it? Can you
Yes,
see
you
it
can
now?
see it. Yes. Yes.
Okay. So what I did was, after it opened this way, then you have to click on the line. By then, there was no values on it. So what you have to do is click on it. You see the whole of it being highlighted. And then place the cursor on the line again. right click, go down, then you see show data labels, and then you show before the numbers here will appear. So mostly it is always good when you leave the line in black color. But if you want to change the color of the line, even though this is the best one, the black line, that is the best practice in thesis. But if you want to change it just for our learning practice, you can just click on it. You see the whole of the line being highlighted. The way you did the other way, the other ones, you come here and then select any color that you are interested in. Let me say red, and then you apply. You see the whole of it now turn red. Maybe this color or the labels, the data labels, you want to also make it a different color, even though it is indicated white and the white is the base. But if you want to change the color, you can just come here, select any color of your interest. So let me say, let me put this one, the light one. And then sorry, click elsewhere and then click on it again. You see them all highlighted. Then you click on this one and then you apply. No. Good. So now everything it has now been changed. So you can just be doing this and editing it one after the other. So today we have covered the reliability and the validity, which I explained that when you get the variables or the data, you have to test it first, whether it can actually achieve the objective of your study by using the reliability and the validity. And then the next thing we did happens to be the demographic variables. Once it is being achieved, the reliability and the validity is being achieved, then you move further by running the demographic information and then you report it. And the next one we did happens to be the graphs, the 4 graphs. I think our next meeting, we continue with the normality test. Please, do you have any question for today's class?
Yes, I have a question.
Okay, boss,
So
you can go ahead.
you ran the reliability test and then it fall below the threshold. What are you supposed to do?
So it means the data cannot achieve your objectives. So your supervisor will ask you either you make adjustment to the data or the data should be rejected.
Okay.
That means whenever the objective of analysis is, you should be able to achieve the objective of your research. So when you test your data, the data that you want to use to analyze to achieve your objectives, and the data or the concept is saying that the data is not reliable. That means how then do you defend it? So either you change the data completely, or maybe something is wrong elsewhere. You have to adjust the values. Do you get it?
Okay, but are there possibilities that maybe some of the items can be taken off and then maybe perhaps
Yes, that is why I'm saying adjustments. Maybe you are taking something off, you are adding something.
Okay.
That is what I mean by the adjustments.
Okay, sure. Thank you.
Okay, you're welcome. Any other question?
Yes, Doc.
Yes.
From the time you drew the line graph,
Okay.
I couldn't see anything again.
Okay, so you want me to redraw it or after the
Yeah,
line graph editing?
I also plan like introducing the year data.
Okay.
So I go to a certain point and it's like I have to enter it for a long time before I complete. So I stopped then. I couldn't see what you did.
Okay. So I just entered the year data. You saw when I entered it. So in doing the line graph,
So please, did you enter it one by one?
I entered it for some to some level. Then I was copying, pasting in order to be fast.
How did you do your copy and pasting?
Okay. Um, can you see the data?
No, please. Okay, it's now there.
Okay. So what I did was you have to highlight it. So when I highlight to this level, maybe I can just Control C and then come to this side, Control V, and then it will replace. So when I put Control V, then it will follow, just like the normal copy and paste, but make sure it still fall within that same category under the year. You don't have to copy from here and come and paste here. Then after that, we did the line graph by going to the graphs and then legacy dialog. And then we select the line. We choose the simple. And then we leave the first part, summaries of groups of cases. We leave it checked. And then we define. Now we make sure we check other statistics. Example mean because it's quantitative data. And then we have to move our practices into the variable. And we are measuring it on year. So it was this way. Let me reset it. So it was this way. Then we have to select other statistic and then come down here. What are we interested in? We are interested in the practices. Then we push it to variable. And then we are measuring it by year. Then we push the year into the category axis. And then we say, okay. So when we say, okay, we generate this output.
Okay.
We generate this output. Then we just go and then do some editing to it. That is basically how we did it.
Oh, okay.
Please, any other question? Is Dr. Aren around?
Yes, Doc, I'm here.
Okay, so if they don't have any question, maybe you can close us.
Okay, so thank you so much, Dr. Basiru, for the session. And I think next week we have the new session scheduled and we'll communicate ahead of time. So you prepare towards that. And so in the absence of further questions to our facilitator.
Please, last something, please. I forgot. Doc.
Yes.
Please, can you help us with some small notes? Because maybe after we can easily forget, especially how you put some command to change the data yesterday.
Okay.
Those commands, and as we are also selecting transform, graphs, and other things, maybe some small tips to help us.
Okay.
And also, you use a certain work to show us something. You are reading for something, and you said you can't share that one with us.
Yeah, that's someone's
Yeah.
work I did for the person. So
Yeah.
not advisable to share someone's.
Yes. Yes. I understand. So if you can do maneuver to do something also for us so that we can also keep it for reference
Okay,
sake, like it will also
okay,
be appreciated. Yeah.
all right, okay.
Yeah. Thank
So
you.
that you
Please,
see how
Doc.
the reporting is.
Hello.
Hello, I can hear you.
Please, the recording that is being done for each section, is there a link to it?
Yes, I think they always share it in the group. Dr. Rain, I think you share it, right?
Okay, we've been
In
sharing
the
the
SPSS group.
NUGS-CHINA YouTube channel. When you type NUGS-CHINA on YouTube, you have access to all the videos we've uploaded.
Okay, so it's on YouTube rather.
Yes, it's on YouTube. So you don't have to wait for us to share the link. It's always updated.
Oh, okay, all right. Thank you very much.
You're welcome. Okay, so in the absence
And please,
absence of further,
Dr. Rain, I'm coming. Just one thing.
okay.
Please, tomorrow I'll post your assignment in the group. And then by Friday, I would like to go through your outputs before we meet on Saturday. Thank you.
All right, so since we have no more issues, I think we can close for now and meet in the next session tomorrow.
Thank you.